Hey everyone, today we're going to take a look at the 2025 HSC Maths Advanced paper, specifically section 2, and it's going to be questions 11 to 22. Okay, question 11 says the graph of a quadratic function represented by the equation h equals t squared minus 8t plus 12 is shown. Find the values of t and h. Okay, question 11 says the graph of a quadratic function represented by this equation is shown, and it gives us the graph. Find the values of t and h at the turning point of the graph. So the turning point, that's going to be essentially when the gradient is equal to 0. So we can say dh on dt is equal to 2t minus 8. Turning point at dh dt equals 0. So 2t minus 8 equals 0, which means t equals 4. And then at t equals 4, you sub it in the equation. And then what you get there is, you get minus 4. So therefore, turning point at 4 minus 4. Cool. Part B says the graph shows h equals 12 when t equals 0. What is the other value for t for which h equals 12? So we can see h equals 12, there's going to be two values. Essentially, we just need to solve the equation. So we need to substitute 12 for h and then solve for t. So it's going to be like this. Subtract 12 from both sides and you get 0 equals t squared minus 8t. If we factor out the t, we get, sorry about that. Factor out the t, we get t outside of t minus 8 equals 0. And that gives us two solutions, t equals 0 and then t equals 8. So therefore, other value is t equals 8 because we're already accounting for the 0 case. Question 12 says, find the equation of the tangent to this line at the point 1 minus 6. So to find the equation of the tangent, we first need to derive and essentially substitute a value to get the gradient at that specific point. So let's just rewrite the equation so that we can actually derive it. So it's equal to 5x cubed minus 2x to the power of minus 2. That's because when a power is on a denominator, to bring it up to the numerator, we essentially turn that we turn the power negative. So this goes to x to the minus 2, and we have minus 9. And now we can derive it. So dy on dx is equal to 15x squared plus 4x minus 3. And then at x equals 1, because we want to find the gradient at the point. So when x equals 1, so at x equals 1, dy dx is equal to 15 outside of 1 squared plus 4, 1 minus 3, which is just equal to 19. Therefore, gradient at tangent is 19. And then we have the formula for a line. So y minus y1 equals m outside of x minus x1. That's the way in which we find the equation of a line given a point, x1, y1, and a gradient m. So now we can just substitute the values. We could say y minus 6, that's our y1, equals the gradient at that point, which is 19, outside of x minus the x point, which is 1. Let's bring that all up here. Then we have y plus 6 is equal to 19x minus 19. And then we have y equals 19x minus 25. And that's our answer. Now we have question 13, which says the numbers 75, p, q, 20, 25 form a geometric sequence. Find the values of p and q. So this one's an interesting one. If it's a geometric sequence, we should know that to go from one value to the next value to the next one, they all have a ratio R. And so essentially what we need to see is that to get from 75 to 2025 or 2025, we need to multiply by R to get to P. We need to multiply by R again to get to Q. And then we need to multiply by that R again to get to 2025. So what we can say is P equals 75 times R, 75R. We can say Q equals 75R cubed, R squared. And then we can say 2025 is equal to 75R cubed. All right, and now, using this equation here, we can solve for R, which then will allow us to get the values of P and Q. So what we have is R cubed is equal to 2025 divided by 75, which is 27. And then we take the cubed root of 27 and we get that R is equal to 3. So therefore, P is equal to 75 times 3, which is equal to, let's see, what is that? 225. And then Q is equal to 75 times 3 squared, which is equal to 675. And that's it. Question 14 says, in a research study, participants were asked to record the number of minutes they spent watching television and the number of minutes they spent exercising each day over a period of 3 months. The averages for each participant were recorded and graphed. And so we've got this graph here that has the minutes per day spent exercising across the minutes per day watching TV. Part A says, describe the bivariate dataset in terms of its form and direction. So form refers to, I guess, the shape of the graph or the shape of the data. And what we can see here is that there's a very clear trend where as we move along the x-axis, the y-axis is going down in a linear direction. So we can see that, if we try and graph an average line, we can see it's essentially a simple line graph. So the form here is going to be linear. The direction, I guess what we can just see using that black line is that it is a downward direction, but more specifically, we need to say that its direction is negative. And that's because as we increase on the x-axis, we are decreasing on the y-axis. Part B says the equation of the least squares regression line for this data set is y equals 64.3 minus 0.7x. Interpret the values of the slope and the y-intercept of the regression line in the context of this data set. So what we need to first off identify is the slope. The slope is going to be, this is written in the form y equals mx plus b, with mx being the minus 0.7x. So that means m is minus 0.7 and b is equal to 64.3. So our gradient is minus 0.7, or the slope I should say, and the y-intercept is 64.3. So now we actually need to interpret these in relation to the actual information we have. So that slope of 0.7, what I'm going to say is the slope. So what this means is minus 0.7 means for every minute that we watch television, so for every minute per day that we watch television, we exercise 0.7 minutes less in that day. So what we could say is for each minute spent spent watching TV, minus 0.7 minutes are spent exercising. Oops. Or instead of minus 0.7 minutes, we can say something like the time spent exercising is 0.7 minutes less. And then the y-intercept. So how do we interpret that? So the 64.3 essentially says, well, if we spend no time watching television, then we will be exercising for 64.3 minutes. So if there is no time spent watching TV, the time okay, that's essentially what we can say there. Part C says, Joe spends an average of 42 minutes per day watching television. Use the equation of the regression line to determine how many minutes, on average, Joe is expected to exercise each day. So let's just rewrite that regression line. Y equals 64.3 minus 0.7x. It says Joe spends an average of 42 minutes per day watching television. The time spent watching television is the x. So that means we have y equals 64.3 minus 0.7 times 42. And we can solve for this, and we will get 34.9 minutes. Part D says, explain why it is not appropriate to extrapolate the regression line to predict the average number of minutes of exercise per day for someone who watches an average of 2 hours of television per day. So yeah, a lot of words in that question. Essentially, it's saying, if someone watches television for 2 hours, why can't we use this regression line? Or why is this data not appropriate? And what we should be able to just identify first off is this graph only goes to 60. Now, if we were to extend this dotted line past that, we can keep going down. And we should be able to see that, well, we get into a negative number of minutes per day that we're exercising, which just doesn't make intuitive sense. So what we're going to do in the actual question is we are going to essentially solve it. So we're going to say y equals 64.3 minus 0.7 times 120, because it's 120 minutes in 2 hours. And that gets us minus 19.7 minutes. And then we can say this doesn't make sense, as someone can't exercise for negative time. Question 15 says a sound wave can be modeled using a function pt equals k sine at, where p is air pressure in pascals, t is time in milliseconds, and k and a are constants. Part A says write the equation for a sound wave p1t that has an amplitude of 2 pascals and a period of 5 milliseconds. So amplitude is just k. So we can say k equals 2, because that's essentially represented by the amplitude. Now the period, what we need to remember is that the period is, let's call the period PE. That is 2 pi on B. Or in this instance, instead of B, it's A. So what we say is 2 pi on A is equal to 5, and we get that A is equal to 2 pi on 5. So therefore, P1t, the equation of the line, is equal to 2 sine 2 pi on 5t. That's the equation of the line. Question 15, part B, says the graph of P1t from part A is shown. So this graph here is, let's just rewrite it, P1t is equal to 2 sine 2 pi on 5t. And the question is asking for us to sketch the equation of this line, P2t rather, so that is 4 sine pi on 10t for 0 to 10. Okay, so again, we're going to say that the amplitude, well, we're going to figure out what the amplitude and the period is. So we should recognize the amplitude is 4, and the period is equal to 2 pi on 10, because that is essentially our B value. And so what we get is that the period is 20. What we need to remember is that the period describes when, essentially how long it takes for the graph to return to its starting position. And that is described in this graph by that dotted red line. And it makes sense because remember the period for this line is 5, and it starts repeating itself again. Essentially the behavior of the graph starts repeating itself again every 5 seconds. And we can see, if we see on the next 5 seconds to 10, we see it starts repeating itself after that. Okay, so once that's, I guess, cleared up now, what we should realize is our period is 20 for this new line, this P2t. And that means that for 0 to 10, we aren't going to have a full cycle. In fact, we're only going to have a half cycle, so something like this. Because essentially 10 is half of 20, and so the graph itself, we're only going to be seeing one half of it. So if you imagine what a sine curve looks like, we go up, then down, and then up again. We're just going to have this portion. Okay, so now we're going to use all this information. We're going to use the fact that we have a period of 10. So we start here, we're going to end here. And it's an amplitude of 4, which means our peak is going to occur in the middle, so at 5, and we're going to hit that coordinate of 5, 4. So it's going to look something like that. And that's essentially our sketch for 15b. Part C then says, hence find the values of t for where from 0 to 10, for which the functions P1t and P2t are both decreasing. So we just need to use the sketch, and we need to say, well, P2t is decreasing from 5 to 10, because it's essentially decreasing from here to here. It's constantly going down. And P1t is decreasing from, now where is it decreasing? It's decreasing here, and it's also decreasing here. And these values, essentially by using the period, what we can infer is that these values are 1.25, 3.75, 6.25 is this value here, and this value here is 8.75. So it's decreasing from 1.25 to 3.75 and 6.25 to 8.75. Therefore, both are decreasing from this here, because essentially if we combine the restrictions of both these curves, so it needs to be between 5 and 10 according to the P2T, and that essentially cancels this out and only leaves us with this as it falls within the 5 to 10 range. So if we combine these two restrictions of where of what values t can hold, that essentially is this range here. That's our answer. Question 16 says, consider the function f of x equals x squared on e to the x. And part A says, find the stationary points of the function and determine their nature. So to find the stationary points of a graph, we should know that we need to derive, set the derivative to be equal to 0, and essentially just go from there. So in order to derive this function, we're going to need to use the VUV rule. And we need to realize that this is in the form u over v, and that f dash of x is equal to v u dash minus u v dash on v squared. So that means f dash of x is v e to the x times u dash, which is the derivative of x squared, which is 2x, minus u, which is x squared, times v dash, the derivative of e to the x, which is just e to the x, all over e to the x squared. And then we can say this is 2x e to the x minus x squared e to the x on e to the 2x, which is just equal to x e to the x if we factorize outside of 2 minus x on e to the 2x. So then we say that the stationary points occur at the derivative to be equal to 0, so f dash of x equals 0. That's where our stationary points are. So therefore we have x e to the x outside of 2 minus x over e to the 2x equals 0. We can multiply the denominator out on both sides and we get x e to the 2x outside of 2 minus x is equal to 0. And then we get three different situations, because what we need to realize is that essentially these are all multiplying by each other. And any one of those three, I guess, can be equal to 0, and that will cause the whole equation to be equal to 0. So therefore, x equals 0, e to the x equals 0, or 2 minus x equals 0. X equals 0 is already solved for us, so that's great. E to the x 0 is no solution, because it never equals 0. There's no solutions for this equation. And 2 minus x is x equals 2. So that means that there are two stationary points for this graph, one at x equals 0 and one at x equals 2. Hope that makes sense. So then we essentially just go one by one, and we say, let's start with x equals 0. So we can say up here, at x equals 0, we have f of 0 is equal to 0 squared on e to the 0, which is equal to, it's just equal to 0. And then what we can say then to determine its nature is we should test how the gradient changes before and after. So if we have something like this, so if we have our x value at 0 and we take a value that's slightly larger and a value that's slightly smaller than that, we should be able to check that there is, if there is some sort of change in the gradient, then that would indicate, or that would be able to determine its nature. So we can say at 0, the gradient is equal to 0. If we sub in 0.1 for the gradient function, what we'll get is a positive value. And if we sub in negative 0.1, what we'll get is a negative value. So that means we look our gradient can be shaped as something like that. So therefore, there is a minimum at 0, 0. And then we need to determine the nature of the other stationary point. But first, let's find its y coordinate. So f of 2 is equal to 2 squared on e to the power of 2, which is just equal to 4 on e squared. And then if we do the same sort of thing, so x, f dash of x, now we have our x value of 2. If we take a value slightly larger than 2, so 2.1, and slightly smaller than 2, 1.9. So at 2, the gradient is equal to 0. If we take a value slightly larger than that, the gradient is negative, and slightly smaller, it's positive. So we have a graph with a shape like that. So therefore, there is a maximum. There's a maximum at the point 2 and 4 on e squared. And that is part A. Part B says a partially completed graph of the function is shown. Use your answer from part A to complete the graph. So what they give us here is essentially, well, what we need to realize is that this graph here is a little bit tricky to actually plot. So they give us, I guess, some hints saying that everything before this point is just going to increase upwards like that, and everything after this point here is going to trend down towards 0, down towards that asymptote of 0 there. Now what we need to do is then just realize that, well, what we've done in part A is find a minimum at 0, 0 and a maximum at 4 on e squared. Now if we look up the value, if we put in our calculator the actual value of 4 over e squared, it is 0.54. And so that means we can just plot something like this. So this is going to be our minimum at 0, 0. And then at 2 and 0.54, which is just above 0.5, let's call it here. That's our maximum. So we just fill in the blanks, ensuring that we have a minimum and maximum at those specific points. And then we should just always label 4 on e squared. And this is 0, 0. That's a 0, 0 there. And that's it. That's our graph. Question 17 says a borrower obtains a reducing balance loan of $800,000 to buy a house. Interest is charged at 0.5% monthly, compounded monthly. On the last day of each month, interest is added to the balance owing on the loan, and then the monthly repayment of $5,740 is made. Let A and B the balance owing on the loan at the end of n months. And then we need to show, I guess, that A2 is equal to this. All right, a few things going on here. We have 0.5% interest monthly, compounded monthly. So there's no need to change the interest rate because it's already in a month and we are compounding monthly. Then we say on the last day of each month, interest is added. So we add on interest and then the monthly repayment is made. So that means what we should say is that, well, A0 is equal to the starting value of the loan after no repayments are made, so 800,000. And then A1, which is the balance owing on the loan after the first month, is, well, we take the 800,000. We multiply that by our interest, which is 1.005, and then we subtract 5,740. And that's what we get. Now we're not going to solve this because I guess we need to get it into a form that looks like A2. And then what we need to say is, well, okay, A2 is going to be the value of the loan, A1, times that interest, 1.005, minus 5,740, so minus our repayment. That means if we then substitute A1 for what we have over here, we then get A2 is equal to 800,000 times 1.005 minus 5,740. All of that, which is A1, gets multiplied by 1.005, and then we subtract 5,740. If we multiply the 1.005, like this one here, into this square bracket term, what we get is 800,000 outside of 1.005 squared minus 5,740 outside of 1.005 minus 5,740, which is exactly what they wanted. And so we've completed part A. Part B says show that AN is equal to this equation here. And to solve this, what we need to see is a developing pattern in the way that the amount is constructed. So we can see that, if we follow the rules of A2, what we have is this 800K, this 800,000, being multiplied by the 1.005, and the power is 2, which is, I guess, matching what we had over here. And then we have minus 5,740 times 1.005 to a power that is 1 less than what we had before, minus 5,740 times a power that is going to be then 2 less than what we had, and it's going to work in that way. So what we can say is AN is equal to 800, or we should say by continuing the pattern, just so that I guess the marker is aware that this is how we're solving this. By continuing the pattern, AN is equal to 800,000 outside of 1.005 to the power of n minus 5,740 outside of 1.005 to the power of n minus 1 minus 5,740 outside of 1.005 to the power of n minus 2, and then minus, and then essentially we have dot, 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 all the way to a single 5,740. What we can then say is, or at least realize, is that all of these 5,740 terms, all of them can be considered a GP. And we can, I guess, to reveal that a little bit more, we can factor out 5,740 and realize that then this becomes 1.005 n minus 1 plus 1.005 n minus 2 plus all the way to 1. And I guess if we wanted to reorder the sum of those brackets, we can, and that would make it a little bit more revealing. So we would have 1 plus 1.005 plus all the way up to 1.005 to the n minus 1. And then, so we can treat this as a GP with r equals 1.005 and n is equal to n. Like the number of terms is n. So we can say it's equal to 800,000 outside of 1.005 to the power of n. Now we should know the formula for the sum of a GP, which is r to the n, so r 1.005 to the n minus 1 over r minus 1, 1.005 minus 1. And then we I guess, just sort of solve accordingly. Now this step is very important. We need to essentially do this calculation. We need to take 5,740 and divide it by 0.005. That's what we're going to do. That value is going to be equal to 1,148,000 out of 1.005 to the n minus 1. And then we can just expand the bracket So once we've expanded that, then we can, I guess, just collect like terms. So these two terms are like because they both have the 1.005 to the power of n as the common term. And then what we end up getting is what we need. So then we get 1148,000 minus 348,000 outside of 1.005 to the power of n. Part C then says, after how many months will the balance owing on the loan first be less than $400,000? So what we need to realize is that, well, we need to use that first part. So AN is equal to this equation here. And n is the number of months. And so we need to solve for n, that given that AN is less than 400,000. So we have 1148, so 1,148,000 minus 348,000 outside of 1.005 to the power of n. When is that going to be less than 400,000? So we have minus 348,000. If we subtract the 1.148 million on both sides, we end up with this. And then if we divide by negative if we divide by negative 348,000, we end up with this equation. Now, because we're dividing by a negative number, remember we flip the inequality, and then we get 187 on 87. We essentially log both sides so that we can get the n in a solvable form. And then we get n is greater than ln 187 on 87, all divided by ln of 1.005, which is, so n is greater than 153.4 months. So that means the first month in which the balance will be less than 400,000 is the 154th month. Therefore, it takes 154 months. And that's it. That's our answer. Question 18 says, find the range of g of f of x given f of x is 3 on x minus 1 and g of x equals x plus 5. So what we need to realize is that g of x is g of f of x is just translating the function up by 5 units. So we've got this x here, which essentially is going to be replaced by 3 on x minus 1. And then we have this plus 5. So it translates it up by 5. So as an example, if we had a chart here and this black line was f of x, the red line would be g of f of x, and the difference between them would be 5 units. That's essentially it. So g of f of x is equal to 3 on x minus 1 plus 5. So it's very simple. But for the range, how do we work that out? Well, the range of g of f of x is going to consider the range of f of x firstly, and then it's just going to be translated up by 5 units. So what is f of x? F of x is a hyperbola, and it is going to look something like this. And we can see that there is an asymptote at y is equal to 0. That essentially describes what the range is going to be. So we can say range of f of x is minus infinity to 0, not including, and the union of that and 0 to positive infinity. So therefore, the range of g of f of x is going to be that range of f of x, but just translated up by 5 units. So it's equal to minus infinity plus 5, which is still just going to be minus infinity, to 0 plus 5. So instead of 0, it's now 5. Union 5 to infinity. And that's what our range then becomes. That's the answer. Question 19 says 3 girls, Amara, Bala, and Cassie, have nominated themselves for the local soccer team. Exactly one of the girls will be selected. The chances of their selection are in the ratio 1 to 2 to 3, respectively. So that means A to B to C, if we're taking Amara as A, Bala as B, Cassie as C. Probability that the team wins when Amara is selected is 0.5, Bala selected 0.4, Cassie selected 0.2. Given that the team wins, find the probability that Amara was selected. So this is obviously a probability question, but more specifically, it's a conditional probability question because we have this given statement. So given that the team wins, find the probability Amara was selected. So this isn't the same way of saying probability that Amara was selected given team wins. And that's just equal to, or what we should know by conditional probability is this is equal to the probability that A and W both occur over the probability of winning. So the probability that Amara is selected and they win, all divided by the probability that they are going to win. All right, so what is the probability that Amara is selected and that they win? Well, that is, well, first off, it's the probability that Amara is selected, and then they need to win given that Amara is selected. So win given Amara is selected. Now the probability of winning, the denominator, essentially just considers all the cases. So they can still win regardless of whether Amara is selected or not. So they can still win if Amara is selected, Bala is selected, or Cassie is selected. So that means the probability of winning is, well, probability that Amara gets selected times the probability they win given Amara is selected, plus the probability that Bala is selected times the probability they win given Bala is selected, plus probability that Cassie is selected times the probability they win given Cassie is selected. Let me just extend the denominator there. And yeah, that is essentially the formula that is going to describe our probability. And well, how do we get all these values? Well, the probability that Amara, Bala, or Cassie is selected, that is given by this ratio here. Now it's 1 to 2 to 3. So that means the probability of A is equal to 1 out of the total number of parts that they have. So 1 plus 2 plus 3 is 6. So 1 out of 6. Probability of B is going to be equal to 2 out of 6. And the probability of C is equal to 3 out of 6. These dot points here, the probability that the team wins when Amara is selected, Bala is selected, Cassie is selected. This is the same as saying they win given Amara selected, win given Bala selected, win given Cassie selected. And now that we've, I guess, figured all of this out, we can then just substitute the values into the equation. So we get the probability that Amara is selected, which is 1 in 6, times the probability that they win given she's selected, which is 0.5, all divided by that same thing again, plus the probability that Bala is selected, which is 2 in 6, times the probability they win given Bala is selected, which is 0.4, plus the probability of Cassie being selected, which is 3 in 6, times the probability they win given Cassie is selected, which is 0.2. And we get, if we just plug this all into a calculator, we get 5 on 19. That's our answer. Question 20 says the table shows the future value interest factors for an annuity of $1. Then it says Lynn invests a lump sum of $21K for 7 years at an interest rate of 6% per annum, compounded monthly. Yemi wants to achieve the same future value as Lynn by using an annuity. They plan to deposit a fixed amount into an investment account at the end of each month for 7 years. The investment account pays 6% per annum compounded monthly. And we want to determine how much Yemi needs to deposit each month. So the first thing is, well, we know that Yemi wants to get the same future value as Lin. So what is Lin's future value? Well, this is just going to be a simple compound interest formula. So we take the principal, 21,000, we take it as 1 plus the interest rate. Now the interest rate is 6% divided by 12 because this is compounded monthly and the 6% is per annum. To the power of however many months we're compounding it for, so because it's 7 years, it's to the power of 7 times 12. Now that is all going to be equal to 31,927.76. And well, we should now know that using a annuity table like this, we should know that whatever the factor is, multiplied by the monthly amount, M, let's call it. So M times the annuity factor, let's call it F, should be equal to our future value. So that means the monthly amount times this F, which we're going to figure out, is going to be equal to 31,927.76. Now this F though, this annuity factor, what is that equal to? Well, we know that we are compounding monthly, which is the most important thing to look at because that's going to determine the rate and the period that we're going to be using for the annuity. And also Yemi is depositing each month, which I guess makes sense with that. So it's going to be for 7 years, and similar to what we did here, it's 7 times 12, and that is going to be 84 periods. And then on top of that, we have a 6% per annum interest rate, which is 0.5% if we compound it monthly, which gets us here. And so that means if we line up, I guess, the annuity factor where we have a 0.5% interest rate over 84 periods, we get this factor. So 104, I haven't left myself enough space to write it, but I'm just going to say it's 104. But in my calculator, I'm going to put this actual number here. And then if we just divide the two, we get M is equal to 31,927.76 divided by 104.07393. And that gets us at $306.78. And that's how much they will need to deposit. Question 21 says a continuous random variable x has a probability density function given by this function here. Find the mode of the given probability density function. Justify your answer. So the mode is the most common value. And for a probability density function, this is essentially going to be the maximum value for the function. So what I would recommend doing though, to find that maximum value is understand whether the graph is increasing, decreasing, just figuring out what is actually happening in this graph. So we have f of x is equal to x to the minus 1 for 1 to x to the e. And that means f dash of x is equal to minus x minus 2, or in other words, minus 1 on x squared. Now what we need to realize is that x squared is always positive or greater than 0. Therefore, minus 1 on x squared is always negative. Is always less than 0. So that means because the gradient, or f dash of x, the gradient curve is always 0, therefore f of x is always decreasing. And because it's always decreasing, that means the largest value of f of x is going to be at the lowest value of x. And for this domain here, it's at x equals 1. So we can say, therefore, largest value is at x equals 1. Therefore, mode is at x equals 1. And that's it. That's part A. Part B says calculate the value of the 25th percentile, Q1, of this distribution. Give your answer correct to 3 decimal places. So to find the 25th percentile, we need to realize that, well, if we integrate the probability density function, we get the cumulative, we get essentially the cumulative probability function. And that means integrating from 1, which is our lower bound, to some value k, which is going to be the value of the 25th percentile. So if we integrate this, which is just x to the, which is 1 over x rather, dx, we want to get this equal to the 25th percentile, which is 0.25. So the area under that curve needs to be 25% or 0.25. And the value k that we integrate up into is going to be the value of that 25th percentile. Now we should know that the integral of 1 over x is ln x, and that equals 0.25. And then we have ln k minus ln 1 is equal to 0.25. We should know ln 1 is just equal to 0. So ln k is equal to 0.25. And that means k is equal to e to the 0.25, or is equal to 1.284 to the nearest 3 decimal places, as the question specifies. Question 22 says that we need to prove this trigonometric equation. So what we're going to do is we're going to start with the left-hand side, and we're just going to re-quote what that was. So it's sine to the power of 4 theta plus cos to the power of 4 theta over sine squared theta cos squared theta plus 2. And if we want to try and, I guess, just make this all into the same fraction, then this is going to be sine to the 4 theta plus cos to the 4 theta plus 2 sine squared theta cos squared theta all over sine squared theta cos squared theta. And I'm just going to rearrange the numerator to look something like this, because this is maybe something that is a little bit tricky to see and takes a bit of practice to understand, or at least realize it, especially in an exam. But the numerator right here is a perfect square. Now, what is it a perfect square of? It's a perfect square of, I'm going to write it down here. So sine squared theta plus cos squared theta. So if we square all of that, we get this numerator here. And the reason being is, well, what we know about perfect squares is that a plus b all squared is equal to a squared plus 2ab plus b squared. Now, if you replace a with sine squared and b with cos squared, then you'll see how this equation here is equal to this. Okay, hope that makes sense. And this is all going to be over that denominator of sine squared theta cos squared theta, which is equal to, well, we now know sine squared theta plus cos squared theta is 1. So it's 1 squared, which is actually just 1. So I'm not even going to bother writing the squared, over sine squared theta cos squared theta. And now we should realize that this is just going to transform into this. So we can just say, well, the 1 over cos squared turns into sec squared. And then 1 over sine squared turns into cosec squared, which is equal to the right-hand side. And therefore it's done.